Hi, Assalamualaikum. My name is SYAFIQAH binti SHAFFRY and my partner's name is FATIN SYAHIRAH binti ZAIRUL AKHBAR. So we are from group 4. So for this mini project, we choose to do a water level indicator. So let's get started. So what is water level indicator? A water level indicator is a series of electronic to detect the level of water in the tank. It can be used as a water level meter or water level detector. This is to show the level of the water in an overhead tank, useful to inform the user of the water level, whether it is running out, as such to avoid that situation when the water is most needed. It can be used as a water level meter or water level detector. So next, for the concept of this mini project is this water level indicator uses a simple real-time encoding circuit with 7-segment display. So in this project, we just use two IC, which is 3 to 8 encoder IC 74148 and an inverter which is IC 7404. For the encoded level, it will display on a 7-segment digital display, which it will display at a hexadecimal LED display. Next, this is our block diagram. So from power supply, we use a wire as a liquid sensor, and then we connect it at the tank and we connect it to the 3 to 8 encoder, which is IC 74148, and then from the from the encoder, it will connect it into an inverter, which is IC 7404, and then it will display the level of water at the hexadecimal LED display. So next, for the implementation operation of the circuit, so here's the component that will be used in this project, which is power supply, 3 to 8 encoder IC 74148, an inverter which is IC 7404, and lastly we will use hexadecimal LED display. So here's the bill of material. So here's the component, here's the price and the quantity. So the total for all the component that will be used is 13 ringgit and 40 cents. So next, here's our circuit diagram for this mini project. So as we can see here, this is the water tank, and then this is the wire as a liquid sensor. Like as I said before, this is just this wire for a water level indicator, and then from the wire it will be connected to encoder, and then from the encoder it will be connected into the inverter, and then it will be displayed at the hexadecimal LED display. So that's it for me. So for the next, I will pass it to my partners to explain it about this project.
For part simulation, me, Nufati Shaira, will explain. We use multi-sim software to recreate our circuit in form of schematic and 3D view from PCB layout. To begin with, I will explain based on how it operates. Okay, firstly, the switch on, which is 0, indicates that the water is touching the point at wire sensor. We consider that the water is empty at initial. When the water touches the point at D1 of encoder 8 to 3 input line, IC is equal to 0. The input pattern is 1111110, which encoded to 110 binary value. The inverted output is 001. It display 1 on hex display. When the water level reaches at 7, it indicates that the water tank is nearly full. Okay, so as you can see, this is the schematic circuit of our mini project that we use from multi-sim software. The components are the input that consists of 8 input from D0, D1, D2, D3, D4, D5, and D6, also D7, that indicates the water level in the tank. IC 74148, which is the encoder of 8 to 3 input line. VCC power supply, inverter 7404 IC, and BCD hexa digital display. 74148 IC, it has 16 pins, which we call as octal to binary encoder. Pin 1, 2, 3, 4, 10, 11, 12, and 13 is decimal data input, or we call as active flow. Okay, pin 16 is to supply the voltage that is connected to VCC power supply. Pin 6, 7, and 9 is binary address output for active flow. The binary output, or we call as BCD, is another way to present decimal numbers in 4-bit binary form. It can never be greater than 9. The BCD will connect it to IC7404 and it will be inverted before that. Then after that, it will be connected to BCD hexa digital display. From left is the most significant bit of binary outputs, while the right one is the lowest significant. Okay, when I run the simulation, this is to indicate that the water in the tank is at level 0, or we call as empty. Okay, when the water level at 1, the D1 input will trigger. And then when I select the D1 as 1, which is the switch is off, while the D0 is on, so the digital display will display as the water is empty. I put D2 as 0, the water is at level 2, and then when I select at D3, the water level is at level 3, D4 is at level 4, D5 is at level 5, D6 is at level 6, and D7 is at level 7, or we call as the water tank is already full. Okay, so this is the PCB layout of the schematic circuit that we create from the multi-sim software. This is the 3D view components. And then this is the truth table of the circuit that consists of 4 columns, which is select inputs, outputs at inverter, and the digital display decimal. Okay, so at the select inputs, we set the inputs have 8 inputs, which is each input indicates the water level of the tank. The outputs is the BCD outputs at the IC74148. Okay, and then the inverter one is after it inverted by IC7404, and then the digital display when the binary outputs is converted to DESI. Okay, so this is when D1 is equal to 0, it will display 1. D2 at 0, it will display 2. D3 at 0, it will display 3. D4 at 0, it will display 4. D5 at 0, display 5. D6 at 0, 6. And D7 at 0 will display 7. Okay, that's all from us. Thank you, ma'am.